So we've got our app working and a little bit more customized so that we can make it work on any platform, which is wonderful. So let's take a look and get this thing Dockerized. So you'll need to install Docker for whatever platform you're on. On Mac, you can just download and install this. There may be some other instructions to get it set up on the command line, but go ahead and follow the instructions for Docker. And what Docker does is it sets up a Linux virtual machine that, for Mac at least, it sets up a Linux virtual machine that runs on your computer. And any components you build, or any Docker images you build, run basically independently in a containerized package on that virtual machine. So they'll have their own dependencies, they won't interfere with each other, and if one crashes, the others keep running. So it's a handy tool. And with Docker, once we have this thing put together, we can hand a Docker image to any platform, and as long as it has Docker, it can run it. So we've got Docker installed. We need to tell Docker how to build an image of our app. So to do that, we're going to need to make a Docker file. So I'll make a new file, capital D Docker file, and there are VS Code extensions for Docker, which are kind of handy. You'll see my code may be highlighted in ways that are different from yours, and that's fine. To start with, we're going to start with a starter image. So there's already an image put together. We're going to start from there and build onto it with things that our app needs. So we're going to do from Python 3.9 Slim Buster. And so that's the image we're starting from. And if you do a search, Python Docker images, it'll bring you to Docker Hub, and you can look. And there are a whole bunch of different images that have been made to work with Python for Docker already here, different versions of Python and so forth. Alpine means it has only the essentials installed. So Python, in this case, probably Python and almost nothing else. I went with Slim Buster because it has a few other things which are handy for Flask. So, but that's there. And then, but we do need to install a few extra dependencies. So these are things for the operating system. And if you're familiar with Homebrew on Mac, this is we're going to be doing a command that's kind of like Homebrew but for Linux, because this runs in a Linux virtual machine. So we're going to run app.get update and app.get install -y, so it doesn't ask us if we want it to install. I'll just put it all in one line. Build essential and lib pq-dev. I think this is library for Postgres development. And this is probably not necessary, but I'm making an environment variable called Python buffered and setting that to true. And yeah, I think it's capital T. And this is just so that any error messages with Python get output immediately. We don't have to wait. And I'm going to make a /app directory. And I'm just going to set an environment variable for my app home to be /app. So I made a folder called /app, and saved it in this variable. And that's where I'm going to do all my work on the container. So I've made a folder in the container, and that's where I'm going to do all my work. So the first thing I'm going to do is install my Python dependencies. And I can do that by doing copy requirements.txt to my working directory there. And then I can run pip install -r requirements.txt. So I copy just the requirements.txt file over, and then I install all the dependencies. And the reason I do this is because Docker remembers each step in the process here. And if nothing is changed in my requirements.txt file, it will basically cache this. And then if something later on changes, it won't have to redo all these steps. So I'm also going to do pip install gunicorn. I used to call it Gunicorn, but it's apparently gunicorn. And then I'm going to copy the app from the folder with my Docker file into my /app folder. And I'm also going to expose 8080, which basically means that if my app is going to be running something on port 8080, and I want somebody on my local computer who goes to port 8080 to get my container. So it'll go from port 8080 on my computer to the port 8080 on the container. And I'm going to make a little script to run this. So I'm going to start off with the command. So the command is going to be, I'm going to make a folder called scripts. I'm going to make a file called entrypoint.sh, and that's how I'm going to start the app. And to get this to work, we probably also need to run changemod +x. So when our container starts up, it's going to run this script file that we're going to make. And I've just made sure that that file is executable on the container before we start. So let's see if we can actually run it. We haven't actually made the entry point yet, but we can still build the image and see what happens. So I'll say docker build dot. So I'm going to build the current directory. And we're going to do a -t, which is tagging it or giving it a name. So I'll call it task list API. And it's going to run. So it's pulling the 3.9 Slim Buster. So it's downloading that from the internet. When you do run this, you might as well go get a cup of coffee. It'll take a few minutes. And then now if you look, it's doing the other commands. It's installing things, running pip install, copy things, and it has an error because I don't have a scripts directory, which is fine. So I'm going to say make directory scripts and touch scripts /entrypoint.sh. And so in my entry point, so this is going to be what they call a bash script. So, and we're going to run basically one command. We're going to run this app through gunicorn. So user local bin /gunicorn --bind. So we're running this, and we're going to run it with whatever port variable is in the operating system. So --workers 1 dash dash threads 8 dash dash, I'll put a, yeah, I'll just do dash dash timeout 0. Oops. And let's turn on word wrap. So, and main colon app. So when we run our app, we're going to be basically running main. So there we are. You can always futz with this for performance. So if you have a beefier server or something you're deploying things to, you can increase the number of workers and threads. Threads are basically the number of things I believe one worker can handle, and so forth. So, but this will work for now. And so now if I go back and do my Docker build, it runs, and you notice it's a lot faster now. And it built, and it worked. So we've built it, and we can run it. I'm going to say docker run -it 8080 :8080. So basically when I go to port 8080 on my computer, it's going to forward me to port 8080 on the container. And task list API. And it probably will not work with this because we don't have an environment variable set for the port, but we'll see how it goes. Oh, I have a typo. We need actually a -p before that. So we're going to open up the port 8080 on my computer to go to the container. So it ran, but could not connect to the database because my container has it blocked off. Because by default, my container cannot reach out of the operating system normally. So what I need to do is set up some environmental variables to tell it how to get out of there. So I'm going to make another script file, just because scripts are very useful. So I'm going to do touch scripts docker run.sh, and so, and there we are. And I'm going to put my command back in. And I'm going to give it an environment variable, port equals 8080. And for the next line, another environment variable, db user will equal Postgres. Database password's blank for the moment. Task list DB for the database name. And this I need to set to the actual host that Docker lets me to hit the local host. So I'll do host.docker.internal and db port, I need to put env in front, is 5432. And I need to put because all these are the same command, just kind of spread over multiple lines for readability. Dash IT dash P. I've already done that with the 8080. So, and I can just put my image name, which is task list API. Is that correct? Yes. So I'll save it. And in here I'm going to do change mod plus X. And I'll just make my Docker run script runnable. So now if I do scripts Docker run, and it's not working because it can't use that port. So let's look at that, the Docker main, the main.py. So we can just have this go off because I'm missing a colon here. Because in my entry point, I forgot the colon here. So in my error message, notice it's saying 000 and then 8008. So that was my mistake. So I need to build it again. And you know what? It's a pain having to type the whole build command every time. So I'm going to do touch scripts docker build. So this way I don't have to remember the command every time. So let's see. bin/bash. And I can do docker build dot dash t, and you put my image name in. So I'll make the script executable. So change mod plus X, docker build.sh, and run the docker build command. That runs pretty quickly. And I can go back and do my docker run. And it seems to be working. And if I pull up localhost 8080, I can access the root route, and I can do that. I could test this with Postman, which would be a really good idea. I am not going to, however, in the interest of time. So we have now Dockerized the app. So we can build it with a Docker component using this docker build command. And when you do that, it reads the Docker file, which starts from an image, installs dependencies, opens up the port you want the website to run on, and starts it with a specific script, which in this case, the script we're running just runs gunicorn on basically localhost at whatever port we've given it. And when we want to run it, we use docker run and -it. And we're going to open up the port 8080 to go to the Docker containers port 8080. And we passed in what really amounts to a bunch of environmental variables for the container to use. Okay. So In the next lesson, we're actually going to start to get into Google Cloud. We're going to go into the Google Cloud Console, make a project, and talk about the SQL, the Cloud SQL database that we're going to use.